So I'm going to proceed and continue from where we left off originally. So here we are. What do we do next at this particular point in time? Well, I could employ the concept of division of indices. And what do I basically do here? What I'm basically going to do here is simply, I'm going to separate this into 2 raised to the power of 1 all over 2 raised to the power of 2 over 3. And then multiply to 5 raised to the power of 2 over 3 divided by 5 raised to the power of 2 over 3. Yeah, that's what I'm basically going to do at this point. And why am I doing that? I'm doing that simply because I see a pattern here. Everything here is divided by this. This 2 raised to the power of 1 times 5 raised to the power of 2 over 3 is divided by 2 raised to the power of 2 over 3 times 5 raised to the power of 2 over 3. So what I'm going to do, what I basically did was to separate it. Okay, because there's an invisible multiplication sign here. It's still multiplying. They're still the same thing. You can join this back according to fraction rule and you still get back this. And at this point, I can now apply the division law of indices, which I can just simply bring this up or I can solve this immediately. Because I see like a pattern here. This, what is on top here is something that is on the bottom here. This can cancel out. So this is already equal to 1. So everything here is equal to 1. Then what is just remaining is this. So what do I do? I'm going to bring this up to become 2. This division becomes divided by 2 to the power of 2 over 3. Now, this is 2 raised to the power of 1. I cannot apply the division law of indices. And how do I go about doing that? Quite simple. To do that, all I need to do is, since the bases are the same, I'll bring one of the base and then subtract, because division of indices simply means subtraction of the power. Subtract the power. 1 minus 2 over 3, and that will give us 2 raised to the power of 1 over 3. So this is another way of, or one of the ways that you can solve this problem, and this is our final answer. But we can actually put this in another form. Remember, one of the laws of indices states that if I have x as base raised to the power of, let's say, 1 over n, it is the same thing as the nth root of x raised to the power of 1. And we know that this power of 1 we can actually skip it, because anything raised to the power of 1 will still give us back that thing. So here we can simply employ that rule here and replace this 2 raised to the power of 1 over 3 as the cube root. If we have 2 here, it means square root. If we have 4 outward here, it means fourth root. If we have 3, it means what? Cube root. So it goes in that order. So let us continue. So at this point, this is going to be the cube root, which is the power of the denominator, cube root of the base. The base is what? 2. Then everything raised to the power of 1, which is the same thing as the cube root of 2. There is no standard whole number value that gives us. So this is another way of representing this answer in this form. So we've actually gone through this process to solve this question. We have one more question to attempt for tonight, and we'll call it a day. I'm going to clean up, take a picture or take a screenshot of what we solved, the solution so far. I'm going to clean up in 5, 4, 3, 2, and 1. So I'm going to solve one more question under these indices before we call it a day. Alright, so look at the question that we're going to simplify right about now. So if you have an expression of this sort, 2 to the power of 2x, close bracket 3, and I have another bracket, 3 to the power of 3x, close bracket 2, divided by 6 raised to the power of 6x. We're asked to simplify this given expression. So how do we go about simplifying this expression? Any info in the chat, please? Any info? Anybody have an idea how we can go about simplifying this in the chat? Let's go. Any information, guys? Hello, guys. Welcome. Please drop your location. Where are you joining from? Thank you so much for joining. Really appreciate you guys for being here. Thank you. Thank you. Where are you joining from? All right, so what am I going to do here? Simple. I can first of all employ the bracket power rule of indices, which simply states if I have an expression of this sort, where you have a base raised to a power and there's an outermost power, you just simply open up the bracket and let the innermost power multiply the outermost power. That is what you're basically going to do. So this is same thing as 2, the base raised to the power of 2x multiply 3. That's what you have. Do the same thing here. Multiply 2, because since they are close to each other, there's an invisible multiplication sign here, or you can also use dot for that. Same thing happens here. Pick the base, which is 3, raised to the power of 3x multiplied to 2, that is x side. Then everything here divided by 6 raised to the power of 6x. This is what we have. So what do we do at this point in time? Well, we'll simply multiply, because that's one of the basic things we know we can actually do. So if we multiply this, it's going to be 2 raised to the power of 2x times 3. Somebody help me with the answer in the comment, guys. 2x times 3, what's it going to give us? Let this very interactive. Let's go. 2x times 3, guys. Help me. 2x times 3. Any help? Somebody help. 2x times 3. Okay, I think I'll just proceed. 2x times 3 will give us 6x. So this is simple as 2 raised to the power of 6x multiplied to 3 raised to the power of what? 6x. This is what we have at this point. Then everything divided by 6 raised to the power of 6x. Now, what do you think we can do here? Because we're not done with the simplification yet. What do you think we can actually do here? Well, I could decide, well, since we have that 6 raised to the power of 6x is here, I can decide to separate this 6 to be, this 6 as the base here can be the same thing as 2 times 3. Then everything raised to the power of 6x. I can do that for this because I know that 2 times 3 will give me 6. So I can do that here, and if I come over here, it's going to be 2 raised to the power of 6x multiplied to 3 raised to the power of 6x divided by 2 times 3, everything raised to the power of 6x. So this is what they have at this point. And then at this point, the powers inside will just go and be added on top of the bases that I just formed now. So it's going to be 2 raised to the power of 6x multiplied to 3 raised to the power of 6x divided by 2 raised to the power of 6x multiplied to 3 raised to the power of 6x. So I just simply shared the power that we'll have out here to the expressions that I reduce the 6 to, that is on the inside. So that once you have done this now, it becomes so easy for us to actually simplify it. Why? Because I can separate this to become 2 raised to the power of 6x, 2 to the power of 6x, all over 2 to the power of 6x, multiplied to 3 to the power of 6x, all over 3 to the power of 6x. So that this cancels this, because they are equal to 1. This divided by itself, anything divided by itself will give you 1. So this same thing as 1, and this same thing as 1. So 1 times 1 is going to give us 1. So this is what we have at this point. We'll actually solve this problem, and we'll solve some interesting problems on indices on today's live section. So I'll be live again on Saturday. No, not on Saturday. I'll be live on Friday, sorry. I'll be live on Friday, same time, 4 p.m. Nigerian time. Nigerian time, that's when I'll be live again. To talk about these indices on a whole different level. We'll have algebraic expressions and some other interesting aspects, and from there we'll move on to the next topic. It's going to be quite interesting. Please make sure to join on Friday. And for those that are just joining, this is Uncle Sam. This is what I basically try to do. Try to make being smart in you cool. And I do that by discussing math in such an interesting way that if you follow through, it will be so enjoyable. I really, really appreciate you guys. Thank you for joining today's live stream. But before we go, please can I know where you're joining from? Please, in the chat, please. Can I know where you're joining from, guys? Can I know? We have about 5 people active. Please, can I know where you're joining from? I would really, really want to know. Please. Please, can I know? Please, can you help me by saying something in the chat before we call it a day? Please. Can I know where you guys are joining from? Jean from Lagos. Jean, thank you for joining, Jean. Really appreciate you. Thank you so much for joining. Thank you. I appreciate. Jean, I hope you enjoyed the class. Did you stay through the class, or you just hopped in a while ago? Thank you so much, Jean. I really appreciate you. Thank you for the support. I just started doing this newly 2 days ago, and it's quite fun. And I appreciate you. Thank you for being here. Really, really appreciate you. I'll be live on Friday by 4 p.m. as well, so that we can pick up from where we stopped. Thank you so much. Oh, you just joined. Thank you so much, Jean. I really appreciate you. Thank you for being here. Thank you for the support. Thank you. Thank you so much. So by Friday, we'll continue with the live section. Thank you so much. I really appreciate you guys, and see you on Friday by 4 p.m. Bye.